In this video, I'll be helping you with a math topic called Using Scientific Notation, seen here in the OpenStax College Algebra text. We're asked to do either multiplication or division in each one of these examples of numbers in scientific notation form. Starting with example A, we can use the fact that multiplication is commutative to multiply the numerical portions here. 8.14 times 6.5 would give us a 52.91, and then we can multiply the 10 to exponents portion. And we know that when we multiply with the same base, we keep that base, 10, and we add the exponents. So negative 7 plus 10 would be 3. And while this looks sort of like scientific notation, it's not quite there, because scientific notation only has one digit in front of the decimal, and currently we have 2. However, we've said that whenever that n is positive, that would be a large number, and that when n is negative, it would be a small number. So for now, I'm going to ignore this second part, this times 10 to the third. I'm going to focus on this 52.91, and I'm going to convert that into scientific notation. So this 52 is too large. The decimal needs to move here to give me a 5.291. And I said it was too large. Large means positive exponents. So I can rewrite just this part as times 10 to the, I only had to move it one space. And again, 52.1 is large, so that was a positive 1. I've rewritten this first portion in scientific notation, and I just need to bring down that second portion times 10 to the third, and I can see that this will now combine. So my numerical portion is 5.291. 10 to the 1 times 10 to the 3 is times 10 to the 4 when we add those exponents. This is our correct scientific notation answer. For B, we are dividing, so I'm going to write it as 4 times 10 to the 5th over negative 1.52 times 10 to the 9th. And again, I'm going to do this in two separate calculations. First, 4 divided by negative 1.52 equals a negative 2.63 as a rounded answer. And then for the scientific notation portion, when I divide with the same base, I keep that base. I have the power of the top minus the power of the bottom. So 5 minus 9 is a negative 4. This answer is in its proper form. So we've completed the calculation. Moving to C, rewriting that, we're again multiplying. So the numerical portion, 2.7 times 6.04, gives us a 16.308. The scientific pieces getting multiplied gives us a 10 to the 5 plus 13, so 10 to the 18. Again, this is not quite scientific notation. The 16 is too large. I need to move the decimal one place to put it behind the first non-zero digit. And again, ignoring that second piece, the first part, making that scientific notation, I would need times 10 to the 1. 1 because it's one space that I moved it, positive because the 16 is too large, and I can bring down that times 10 to the 18. In one additional step, these two 10 to the exponents can be combined. We would keep the base, add the exponents, 10 to the 19th. This is our scientific notation solution. For D, we're again dividing, so I'm going to write it as a fraction. The first part's being divided, 1.2 divided by 9.6 gives me a 0.125. The second part's being divided gives me a 10 to the power of the top minus the power of the bottom. 8 minus 5 is 3. And again, this is not quite scientific notation because I need a non-zero number in front of the decimal. So I need to move this decimal back one spot to make it 1.25. And since the problem here, as I'm ignoring the second part, turning the blue portion into a scientific number, it was too small. So I had to move the decimal one place. One place for a small number means that's a negative exponent. And from here, I can bring down the times 10 to the third. We have that one additional step to combine these. Our 1.25 stays the same, times 10 to the negative 1 plus 3, or 2, as our scientific notation. And then lastly, we have e. This time we have 3 numbers being multiplied. And we'll again look at the first part of each of these to multiply. This multiplication gives us a negative 19.65033. Looking at the 10 with exponents, multiplying here, we would keep the base, add all of these exponents, 4 plus 7 plus 5, which is 16. And since this first part is not in scientific notation, I would again ignore the end, and turning this first part into scientific notation would be moving the decimal one place to give me a negative 1.965033. And that is now in scientific notation. I move the decimal one place, and since the 19 was too large, this is a positive 1. Bringing down the times 10 to the 16 means we can now combine those to be negative 1.965033 times 10 to the 1 plus 16, or 17.